Hi everyone, now we are at lecture number 2, calculus. So continuation to lecture number 1, theorem number 3, Cauchy's mean value theorem. So in this the requirement is if function f from a to b to r and g from closed interval a comma b to r. So both the functions having the domain same and codomain same are such that two functions are continuous on the closed interval and the two functions are differentiable on the open interval and the derivative is not equal to 0. G dash of x is not equal to 0 for all x coming from open interval a comma b. Then the conclusion is then there exists a point c in open interval a comma b such that f of b minus f of a by g of b minus g of a is equal to f dash a by d g dash of c, where g of a not equal to g of b. If g of a is equal to g of b, then this value is 0 and something by 0 is infinity. That's why this denominator should not be equal to 0. That's why g of a not equals to g of b. So it's like Lagrange's mean value theorem only, but two functions we have to take at a time, f and g. Okay. So this I will explain in detail in coming modules. Just to remember the theorem statement, I will come into this later. Look at the problem corresponding to this. Find C of Cauchy's mean value theorem for f of x is sin x and g of x is cos x on minus pi to 0. So f of x is sin x. So therefore, what is f dash of x? F dash of x is cos x because it is derivatives required, and second function g of x which is cos x and its derivative g dash of x is minus sin x. Okay, minus sin x. All of you just you go through all the formulas, derivative formulas and integration formulas. So those things are required in this chapter, calculus. Okay, just to recall from PUC, all the derivatives formulas and all the integration formulas. Okay, and what is given? The interval is given. So closed interval a comma b, instead of this it is given minus pi comma 0. So therefore a means minus pi, b means 0. Okay, now let us apply the theorem. F of b minus f of a upon g of b minus g of a is equals to f dash of c upon g dash of c. Okay, so now b means 0, so f, so sine 0. Okay, sine 0 minus sine of minus pi, isn't it? Sine of minus pi upon g value cos, so cos 0 minus cos pi, cos minus pi. Okay, so which is equals to f dash, so cos, right? So therefore cos c. So before entering into mean value theorem, we have to verify both are continuous and differentiable, right? So then only we can apply directly Cauchy's mean value theorem. First we have to verify. Actually, I didn't verify. So f of x is sin x and g of x is cos x. So clearly a sin x and cos x in this interval are continuous. If you look at the graph, what is sin x graph? Actually, we have to verify this. Sin 0 0. So this is the sin x graph. Okay, and minus pi to 0. So this is minus pi, right? So this point is minus pi, and this is 0. So minus pi to 0. So this continuously drawn. It's continuous and differentiable also because it is there is no sharp peak. Okay, so therefore it is differentiable. And simultaneously, what is cos x graph? So like this. Okay, so like this. So this is cos x graph from 0 to 5 again. So this is a piece. So therefore in this interval, so here to here, right? So this is a piece. So it is continuous and differentiable. So therefore sin x and cos x both are continuous and differentiable in the respective intervals, and derivative is not equal to 0. Okay, that means it is nowhere parallel to x-axis for all x in open interval A, comma B. So therefore, see g dash of x is not equal to 0 means derivative is not parallel to x-axis. By using Rolle's theorem, g dash of c equal to 0 means what? The tangent is parallel to x-axis. Not equal to 0 means what? It is does not parallel to x-axis. That means wherever you take the point, the derivative, the tangent. So this is a graph actually. Look at I am writing here. So this is a piece actually, right? So this piece you take. So look at in this interval minus pi to pi. This is a piece. So in this interval, nowhere the tangent is directly parallel to x-axis, right? So therefore, all the conditions of Cauchy's mean value theorem are satisfied. Then we can apply. Okay. First you write here f and g, f comma g are continuous and differentiable. Differentiable. This is compulsory. Verification is compulsory. Differentiable and g dash of x not equal to 0. So therefore, now we can do all these things. Okay. Yeah. So cos of c, cos c upon what is g dash of c, so minus sin c. Okay. So now simplify this. What do you get? Yeah. So sin 0 0, cos minus pi 0. So 0 by 1 is equal to cos c divided by minus sin c. Okay. If you do cross multiplication, we will get cos c is equal to 0. Now can you give me the point at which c, at which cos is vanish? So therefore clearly c value should be so pi by 2, 3 pi by 2, okay, and 5 pi by 2. At all these points it is vanish, and also minus pi by 2, minus 3 pi by 2. So these are negatives, and minus 5 pi by 2, and up to so on. Up to so on. So in this, which point lies in that interval? So minus pi by 2 lies, right? So minus pi by 2 lying in that interval. Yes or no? So this minus pi by 2 lying in this interval. Therefore, so what is c value now? C is minus pi by 2. That's it. So such a point C exists. Okay. C is minus pi by 2 in the open interval, minus pi to 0. And I will come to this later, but just remember as a cautious mean value theorem. Okay. So this is the way of finding C value. First requirement you need to fulfill compulsory. Okay. Next, continue. Taylor's theorem. If f has derivatives of all orders, that means f dash exists, f double dash exists, f triple dash exists, f fourth derivative exists, f fifth derivative exists, up to so on like that. All order derivative exists means that one. In an open interval I containing A. So A is an interior point of the interval I. So some interval you take in that A should be having. Then for each natural number n and for each x in I, each element in I, the function f of x can be written as f of x is writing like this. F at A. What is A? A is an interior point of I. I is an interval. A should be having the interval. So f at that point and first derivative at that point divided by 1 factorial into x minus a. Second derivative at A divided by 2 factorial into x minus a whole square up to so on. Nth derivative at A by n factorial into x minus a whole to power of n plus r and x. R and x is called, this is error. Okay. Where Rn of x is defined as n plus 1th derivative at C by n plus 1 factorial. See all these derivatives at A, but this one n plus 1 derivative at C. Okay, at C. Such C should exist between A and X. Actually, what is I? I is some interval. Okay, some interval, open interval, right? So in this interval, A should be having. So A should belongs to in that I. Okay. Now what is C? C between A and X. For example, look at this. So this is my interval. Okay. And somewhere from here I am taking A. C between A and X. A and X means what? Somewhere you take here X. Okay. So this is my X. Now in this interval, A and X, in this interval, C is coming. C belongs to in that interval. That means after A, indirectly. C should exist after A. At that C, n plus 1 derivative you have to compute. Divided by n plus 1 factor into x minus whole power n plus 1 for some C between A and X. For that C only, this R and X will satisfy. Okay. We'll get into the in detail. Just look at, try to understand what I'm saying. Look at the first note. The function Rnx is called the remainder of order n or the error term. The error term for the approximation of f, this is important, approximation of f over the interval I. So we are approximating f of x. So indirectly what we are doing is, see n we don't know. Okay. So as n becomes large, that means as n tends to infinity, look at the second point also, then I will come to that. If Rn of x tends to 0 as n tends to infinity, as n reaching to large and large, the last term is going to 0. That means error term is becoming 0. See, if error is 0, then we will get exact sum. Right? So our intention is that. So if n tends to infinity, Rnx is going to 0 for all x in I, then we say that the Taylor series generated by f at x is equal to a converges to f on I. That means single function we have taken f of x. That function we are expressing as a sum of infinitely many terms. Look at f of a plus first term plus second term plus third term plus fourth term plus up to so on infinitely many terms. Single function is given to you. You are writing that function as a sum of infinitely many terms. So that is the power of this Taylor series. Okay. So far what you have seen in sequence and series, in series, these terms are given. Right hand side terms is given that for us. But it is reverse. Sum is given directly. So f of x is given. Then what should be series? Reverse question. Okay. Now f of x is given to us. You need to be able to express this function as a sum of infinitely many terms. So that infinitely many terms you need to generate. So that is the power of Taylor series. Okay. So now look at here, as nth term going, as error term is going to 0. If error is 0, then indirectly what is happening? Error, it is null. There is no error. So exact sum, what is the sum of all these terms? It will be f of x. Therefore, this series is converges to f of x. Okay, this entire series is converges to left hand side function f of x. Here, how many terms are there in right hand side? Infinitely many terms. Why? Because n tends to infinity means here also n tends to infinity, right? Nth derivative, so it tends to infinity. So all the derivatives you are taking here. That's why here, look at the first, f has derivatives of all orders that I have taken. It has all orders derivatives in an open interval I. Okay. So now, then this Taylor series we can write like this. So the given function f of x and series k is running from 0 to infinity. If you like k, write k is 0 here. What do you get? Substitute k is 0. So f at a, 0 to derivative of f at a by 0 factorial into x minus a whole to the power of 0. Wherever k, there you write 0 plus, now k0 is over, now k is 1. First derivative of f at a by 1 factorial into x minus a whole to the power of 1. Okay, plus next second derivative f double dash substitute 2, so in bracket you write n is 2 upon 2 factorial into x minus a whole to the power of 2. So plus up to so on. Understood? Now look at here. What is the zeroth derivative of function? See, f is a function first of all. So f is a function given to us. This is a function. F of x is a function, right? Now what is the first derivative of this function? So clearly the first derivative of this function is f dash of x. Second derivative f double dash x, or simply derivatives we should write in bracket like this. We should not write f2 like this. It does not represent second derivative because it represents only f circle f. You have seen in PUC. F square means f circle f. If you write in bracket, it means it is double derivative. That means d square by dx square into f. That's it. Its meaning is this. Make sure all the notations. Okay. Don't confuse with the notations. Yeah. And third derivative means like this. F third derivative or simply f in bracket 3. Okay. That means one time derivative, two time derivative like that. So now what is in the f zeroth derivative? It means what? 0 times d0 by dx0 of f. No derivative. No derivative means what? Function itself, f only. You are not doing derivative directly. One time derivative means what here? Here one time derivative means what? D by 1 times, right? D by dx. So d power 1 by dx power 1, one time derivative into f of x. Because it is one time derivative. It is zero time derivative means what? Power 0 by dx0. Indirectly no derivative. That means f itself. So therefore here no derivative, right? No derivative means the function itself, f of a only. And what do you express the power 0, 1? 0 factorial is 1. So only f of, first term is f of a. That's what you look at here series. First term is f of a. But the second term, f dash a by 1 factorial, f dash a upon 1 factorial into x minus a whole to the power of 1. Similarly, plus second derivative up to so on like this. So indirectly this series you are getting. Got it? Yeah. Next, look at Taylor series of the function f of x e power x at x is 0. I want Taylor series for this. Okay. First, to write the Taylor series of f of x. So f of x is equal to series k is running from 0 to infinity. Okay. F k the derivative at a upon k factorial, right? Into x minus a whole to the power of k. That's what note number 2. Here I have not written error term because error is going to 0. Look at the third point. If Rn x go to 0, second point, as n tends to infinity for all x in I, then we say that the Taylor series is generated by f. So this is called Taylor series. Initially it was Taylor's theorem, right? Now it is Taylor series generated by f at x is equal to e. Converges to f. That means this entire sum is converging to f of x. So that can be written as like this. Okay. So therefore there is no error term here. If error term is 0, then we will get exact sum. If error term is present, we will not get exact sum. So there is error in the sum. Okay. Now we expand it. If we expand this, what will you get? F of a, right? Plus first derivative of f at a by 1 factorial into x minus a whole to the power of 1, right? Plus second derivative of f at a upon 2 factorial into x minus a whole to the power of 2, right? Plus third derivative of f at a upon 3 factorial into x minus a whole to the power of 3 plus up to so on and everything. Up to so on. So infinitely many terms. So all this sum will be exactly equal to f of x, which is f of x. Now we are able to, we need to express f of x e power x as a sum of this, like this infinitely many terms. Okay. Yeah, first we need to find all these unknowns. Say f of x is given to us in the problem itself. X is equal to 0 means what here? A is 0 here. Okay, let me write those things. So what is given to us? F of x is e power x is given. E power x. And what is given? A is 0 given. Taylor series at x is 0 means what? X is equal to a actually. Instead of a, we are having 0. Taylor series at x is equal to a actually. Okay, x is equal to a. But instead of a, what are you having? Here, 0. So this instead of a, you are having 0. That's why a is equal to 0 I am writing. So then what I want? F at a, f dash at a, f double dash at a, all these points I want. So first, what is the derivative of f? What is f dash at x? Which is e power x only. Okay, that implies f dash at a I want. That means f dash at 0. What is f dash at 0? That means e power 0, right? Look at f dash of x is e power x. What is f dash of 0? E power 0. E power 0 which is 1. Okay. So similarly, third one, f double dash of x. That means take f dash of x and do one more time derivative. Again e power x only. Right? Now this is f double dash at a is nothing but f double dash at 0. Now this is f double dash at 0 means e power 0 again, which is 1. So all the derivatives will be e power x only. So all the derivatives at a means it is 1 only. So you can write up to so on. Okay. Our first four terms you can calculate, then substitute back. Okay. First four terms you compute. Then substitute back. So f of x. So assume this is equation number 1. So 1 implies. So equation number 1 implies, yeah, f of x. F of x means e power x. So e power x is equal to f of a. What is f of a? So from here I can compute f of a. Uh, f of a is nothing but f at a, f at a, which is 0, f of 0. What is f of x? E power x. E power 0, right? E power 0, which is 1. So that is also 1. So therefore, f of a is 1 plus second term f dash a by 1 factorial. Okay. So let me write this in detail so that it will be very clear. Yeah, let me write like that. So first, substitute a is 0. So f at 0 plus f dash at 0 by 1 factorial into x minus 0 whole power 1, because a is 1 I am substituting, and f double dash at a, which is 0, by 2 factorial into x minus 0 whole power 3 whole power 2, sorry, plus f triple derivative at a, that means 0, by 3 factorial into x minus 0 whole to the power of 3 plus up to so on. Okay. Now substitute back all the values. So f of 0 1 plus f dash 0 1 by 1 factorial into x power 1 plus 1 by 2 factorial into x power 2 plus 1 by 3 factorial into x power 3. So this is what e power x expansion. So plus up to so on. So therefore final comment is, so therefore e power x is equals to 1 plus x plus x square by 2 factorial, right, plus x power 3 by 3 factorial, okay, plus up to so on. So this is Taylor series of e power x or e power x expansion. So look at the right hand side terms. So there are infinitely many terms. So if you add all these things, you will get e power x. So this series is converging to e power x. So this is Taylor series. So this is Taylor series. Taylor series at x equal to 0 at point 0. So similarly, look at this one. So this is quite interesting, but don't do the problem like this. So what is given to us? So f of x is x into e power x. Okay, x into e power x, and a is 0 is given. Okay, x equal to a, which is, that means a is 0. Okay, so once a is 0 and function f of x is given, so according to Taylor series, so what is Taylor series? Taylor series is given as what is that? F of x is equals to, yes, what is f of x? F of a plus f dash a by 1 factorial into x minus a whole to the power of 1, isn't it? So plus f double dash at a by 2 factorial into x minus a whole square, right, plus f triple dash at a by 3 factorial into x minus a whole to the power of 3 plus up to so on. So this is Taylor series, right? Now this will be modified as f of x is equals to, yeah, f of a. So that means f at 0, a is 0. So f dash of 0 by 1 factorial Okay, into x minus 0 whole to power of 1 plus f double dash at 0 by 2 factorial, right, into x minus 0 whole power 2 plus up to so on. Okay, so now you don't take f of x as x into e power x and first derivative, second derivative, all the derivatives of this. If you find out, you have to apply UV method because x into e power x, two functions are there. You have to apply compulsory UV method for derivative. So don't do that; it becomes very lengthy. Already you know f of x equal to e power x, right? So we know that. So already I have done first problem. That's what I am writing this one. Otherwise you have to prove it. Okay, we know that e power x expansion, Taylor series expansion is, what is e power x Taylor series expansion? 1 plus x power 1 by 1 factorial, right, plus x power 2 by 2 factorial. This first problem what I did just now. So x power 3 by 3 factorial, right, plus up to so on. So this is Taylor series at x is equal to 0. Just now I did. So then what you have to do is simply both sides you multiply with x. That's it. Okay, multiply both sides with x. That's it. Both sides you multiply with x. Then what do you get? So x into e power x, left hand side, and right hand side x into 1 plus x by 1 factorial plus x power 2 by 2 factorial, right, plus x power 3 by 3 factorial plus up to so on. Now you multiply this. So x into 1 is x plus x square by 1 factorial, plus x power 3 by 2 factorial. I'm multiplying with x. Okay, plus x power 4 by 3 factorial plus up to so on. That's it. So this is x into e power x Taylor series expansion. That's it. Or otherwise you take x into e power x as f of x and find out all the derivatives f dash x, f double dash x, f triple dash x, all those things, and substitute a is 0, then you will get the same series expansion. But it becomes somewhat lengthy. You can do like this also. The same problem comes in exam. First you have to prove this one. This e power x expansion you have to find out first, compulsory. Like first problem, you have to prove this, then after that you multiply with x. That is also simple compared to x into e power x taking as a function f of x. Because doing derivatives becomes difficult here. It becomes lengthy and lengthy. Okay. Similarly, look at the second one. So this is the first one. It's a multiplication kind of. So now second, what is given to us? F of x is, remember point should be same. Here x is 0 only. For example, if x is equal to 1 here, then everything will change here. Compulsory I will take f of x equal x into e power x. If a is 1, then I will do freshly. Take this function and do the first derivative of this function only, second derivative of this function and do proceed the same. Since the point a is 0 same, that's why I'm writing directly e power x expansion is this one. Or, for example, x equal 1 is given. What to do? For same function x into e power x. So instead of finding this one, first you find out f of x equal to e power x first. At x equal 1 you find out. Find out this one. Then later you multiply both sides with x. So that you will get, that will just say Taylor series of x into e power x at x is equal to 1. That's it. Simply you are multiplying with x, nothing else. And here e power 3 minus 3x is given. So already Taylor series of e power x you know. So from this directly substitute wherever x there is minus 3x. That's it. Okay. So that you write, we know that e power x is equals to 1 plus x power 1 by 1 factorial plus x power 2 by 2 factorial, right, plus x power 3 by 3 factorial, right, plus up to so on. Now here substitute back wherever x there is minus 3x. Now 1 plus, so instead of x write minus 3x. So minus 3x by 1 factorial. Next plus minus 3x whole square. If you want to simplify, you can simplify this later, but this is a way of doing. Okay. Another way of doing this is minus 3x whole cube by 3 factor. That's it. So this is the Taylor series of e power x. You can do e power minus 3x. Like this also you can do it. Or simply you can take f of x is e power minus 3x, find out all the derivatives like what I have done in first problem. F dash x you find out f double dash, f triple dash, f fourth derivative, all those derivatives you calculate. Maximum 4 derivatives you calculate and substitute. That's it. Then after that you write dot dot dot. That's it. And find the derivatives of all those things at a is 0. Then substitute in this formula. In this formula you substitute back. That's it. So this is about Taylor series by multiplying and substitution technique. Multiplying with x first problem. This is substitution technique. Instead of x, we have substituted minus 3x. Problem. So write the Taylor series of f of x is sin x at x is pi by 2. Okay. So first, what is Taylor series? You write f of x is equal to f of a plus f dash at a by 1 factorial into x minus a whole to the power of 1, okay, plus f double derivative at a by 2 factorial, right, into x minus a whole to the power of 2 plus f triple derivative at a by 3 factorial, okay, into x minus a whole to the power of 3 plus up to so on, right? Yeah. Now here what is given to us? F of x is sin x. F of x is sin x. And what is given? X is equal to a pi by 2. That means x is equal to a is equal to pi by 2. So a value is pi by 2. Now find out all the unknowns here. So now this becomes, yeah, f of x is equal to f of a. What is a? A is pi by 2. So f of pi by 2 plus f dash at pi by 2 by 1 factorial into x minus pi by 2, x minus pi by 2 whole to the power of 1. Okay. Plus f double dash at pi by 2 by 2 factorial into x minus pi by 2 whole to the power of 2 plus f triple derivative at pi by 2 by 3 factorial into x minus pi by 2 whole to the power of 3 plus up to so on. Okay. Now let us calculate all the unknowns here. So if f of pi by 2 is unknown, f dash of pi by 2 is second unknown, and similarly if double dash of pi by 2 is unknown, and if triple dash of pi by 2 is unknown. Substitute all, find out all those things. Okay. So first f of x is given, which is sin x, right? Sin x. And now what is f at pi by 2? F at pi by 2. That means sin pi by 2. So sin pi by 2 is 1. Sin of 90 degrees will be 1. Right? Next, what is f dash of x? F dash of x is cos x. Right? Now f dash at pi by 2. F dash at pi by 2. That means cos at pi by 2. Cos at pi by 2. What is cos of 90 degrees? Which is 0. Similarly, f double dash at x. That means minus sin x. Cos x derivative one more time is minus sin x. Okay. Now again f double dash at pi by 2. Okay. Which is minus sin pi by 2. Minus sin pi by 2. What is minus sin pi by 2? Which is minus 1. Next f triple dash at x. Third derivative. Which is minus cos x. Sin x derivative is cos x. One more time derivative. Proceed like this. So now f triple dash at pi by 2. Which is minus cos of pi by 2. What is cos pi by 2? Which is 0. If you want, you can find one more time. One more term. F fourth derivative of x. That is sin x. Cos derivative is minus sin x, minus of minus plus. Okay, which is f fourth derivative at pi by 2. What will get? Sine of pi by 2. So sine 90 degrees, which is 1. Which is 1. So up to so on. That's it. So first 4 or 5 times you calculate, that is enough. Okay. Yeah. Then substitute back. So assume this is equation number 1. So 1 implies. Okay. So 1 implies in 1 you substitute all those things. So f of x. What is f of x? Which is sin x. Right. Is equal to f at pi by 2, which is 1. 1 plus f dash at pi by 2. What is f dash at pi by 2? Look at here. F dash at pi by 2 is 0. So 0 by 1 factorial into x minus pi by 2. So indirectly this term completely 0. Okay. Power 1. Next second term. Yeah. Second one is f double dash at pi by 2. What is f double dash at pi by 2? Which is minus 1. So minus 1 by 2 factorial. Minus 1 by 2 factorial into x minus pi by 2 whole power 2. Whole power 2 plus triple dash. What is triple dash? Triple dash is 0. So therefore 0 by 3 factorial into x minus pi by 2 whole to power of 3. Next plus fourth one. Fourth derivative is plus 1, right? So therefore 1 by 4 factorial. 1 by 4 factorial. I have not written, but you can write it. Fourth derivative of pi by 2 by 4 factorial to x minus pi by 2 whole power 4. Okay. So x minus pi by 2 whole power 4. Whole power plus up to so on, right? Compulsory because it is a series, right? So therefore this I can write as so 1 minus 1 by 2 factorial into x minus pi by 2 whole power 2. Next plus 1 by 4 x minus pi by 2 1 by 4 factorial 1 by 4 factorial into x minus pi by 2 whole power 4. Next term is minus. So up to so on, right? Dot dot dot. Okay. So this is Taylor series of sin x at the point pi by 2. That's it. So this is Taylor series of the function sin x at x is pi by 2. So if you change the point, if x is pi by 2, you can write x is pi by 4 also, x is 1 also, x is 2 also, your wish. At all the points we can write it. Next one is Maclaurin series, one more series expansion. The Taylor series generated by f at x is equal to 0 compulsory. So this is very important. Point should be compulsory 0. In just now we did point is x is pi by 2 I did, x is 0 I did in the Taylor series. Taylor series can be at any point, but Maclaurin series compulsory at 0 only. So same Taylor series formula I can use, but instead of taking the point A is equal to something else, I need to take A should be 0. That's it. That is said to be Maclaurin series. Nothing else. That is, so this is our Taylor series, right? At x is equal to A. Now instead of A I have to substitute 0. Look at instead of A I am substituting 0. So x minus 0 whole power k means what? X power k. That's it. So this is what Maclaurin series expansion. Now look at one problem. Write the Maclaurin series of f of x is equal to sin x. At I am not giving. Indirectly, Maclaurin series means what? At compulsory 0 only. That's why point I am not mentioning. The point is mentioned, that is Taylor series. Okay, Maclaurin series compulsory. At 0 we need to expand the series. About 0 we have to expand it. Okay. So therefore, same Maclaurin series is, what is the Maclaurin series? F of x. F of x is equal to, same here only we expand it. K is 0 and K is 1 like that. So first f at 0. F at A, right? But 0 plus f dash of 0 by 1 factorial into x minus 0. That means x minus 0 power 1. X only plus f double dash at 0 by 2 factorial into x power 2 plus f triple dash at 0 by 3 factorial into x power 3 plus up to so on. That's it. So this is Maclaurin. That's it. Next, f dash of x you find out. F dash of x. First derivative of f, which is cos x. Sinus derivative is cos x. Okay. Now f dash at 0. That means cos of 0. How much? 1. Next f double dash of x. What is minus sin x? One more time derivative, right? So now it means what is f double dash at 0? Minus sin 0, 0. right? Next f triple dash at x, which is minus cos x, right? This is what is f triple dash at 0, minus cos 0 minus 1, right? F fourth derivative. So if you're writing this kind of Roman numbers, one like this, 1 by 1, 4, and 3 like this, no need to no need to write in bracket. Writing numerical numbers like 1, 2, 3, you have to write compulsory in brackets. That shows, look at here. Look at the series expansion in the notation. Look at here, first step. K is 0 to infinity, K are written in bracket because it's a numbers, right? So it is a derivative. It shows it is a derivative if you write in bracket. Be clear about notations. Okay, first notation should be very clear. Minus cos x derivative is sin x. Minus of minus plus. Now f fourth derivative at 0 will be 0 and up to so on. Substitute all those things in the formula. It is 1. Then 1 implies. Yeah, substitute back. What do you get? F of x means sin x. Sin x is equals to f of 0. F of 0 is 0. Okay. Let me write. And next f dash of 0. F dash of 0 is 1. So 1 by 1 factorial. Directly I'm substituting into x. So first term is 0. I am not writing. Second term is f double dash of 0 is 0. I am not writing the second term. Okay. So this is 0 and this is 0. First term is 0. I am not writing these two in the formula. And next fourth term is f triple dash 0 is minus 1. So minus 1 by 3 factorial into x cube. Similarly, you calculate only two terms I have written. Few more terms you write. Next term also you compute. Better to compute. Okay. Compulsory at least 4 terms you need to compute. Next, f fifth derivative. What is the fifth derivative of x? Which is cos x. So now f fifth derivative at 0 is 1. Now f sixth derivative, which is minus sin x, which is 0 now. Okay. So f sixth derivative at 0 is, so that will be 0. So minus plus, so 1 by 3. So this one, right? Fourth derivative is what? Next one immediately plus. Okay. What will you get? Fourth is 0, right? Fourth one is 0. So fifth term will remain. Fifth term. So that is a fifth derivative is 1. So 1 by 5 factorial into x power 5. Like this. Next one is minus 1 by 7 factorial you will get. Because sixth term is 0, seventh term will remain x power 7. Plus us. So this is a Maclaurin series of sin x at x is equal to 0. So no need to tell it x is 0. Since it is Maclaurin series, obviously it is x is equal to 0 only. So next one, ln1 1 plus x. So this formula I have used in what conditional convergence series. Ln1 plus x formula used there. Ln2, I remembered x is 1, I substituted ln2 is equal to what alternating harmonic series 1 minus 1 by 2 plus 1 by 3. I remember that formula I used there, right? This formula I used there. Now I am writing the formula. I am generating the formula. Okay, Maclaurin series of this one. So first, what is the formula? F of x is f of 0, right, plus f dash 0 by 1 factorial into x plus f double dash 0 by 2 factorial into x square, right, plus f triple dash 0 upon 3 factorial into x power 3 plus up to so on. So f of x is ln1 plus x, ln1 plus x, right? Now what is f at 0? F at 0, f at 0 is ln1, simply ln 1 plus 0, x is 0. That means it is 0, ln1 0. Next, what is f dash of x? ln1 plus x derivative is 1 by ln1 plus x is 1 by 1 plus x. This is f dash of x. Now what do you want? F dash at 0, right? 1 by 1 plus 0, which is 1 only. Next, f double dash derivative, double dash. This one again one more time derivative. So 1 plus x whole square, u by v method. Okay. Remember u by v formula. So derivative of u by v, is equals to u dash v minus u v dash by v square, right? First numerator derivative and denominator as it is minus numerator as it is u into denominator derivative v dash by v square. That's what. So denominator 1 plus x whole square I have written. And numerator derivative is 0. So 0 into 1 plus x. Okay, 0 into 1 plus x. That means numerator derivative I have written and denominator as it is I have written 1 plus x minus. Now numerator as it is, denominator 1 plus x derivative with respect to x is 1. So this will be minus 1 by 1 plus x whole square. Okay. Now this is now f double dash at 0. What is that? So minus 1 by 1 plus 0 whole square. And how much it is? Simply minus 1 only. Similarly f triple dash at x. So f double dash is this much. Now again same UV method. 1 plus x whole to the power of 4 now. Already square is there, one more time power 2. So power 4. Now numerator derivative minus 1 derivative is 0 into denominator 1 plus x whole square is as it is. 1 plus x whole square as it is. Minus. Now numerator as it is minus 1 and denominator derivative I need to proceed. What is the denominator? 1 plus x whole square. Its derivative is 2 into 1 plus x and by chain rule x derivative is 1. Okay, by chain rule. Now this is, so f triple dash at 0. First term is 0, so minus 1 minus plus 2 into 1 plus x. So 2 into 1 plus x upon 1 plus x whole power 4. So one time power cancel out, so we will get 2 by, isn't it? 2 by 1 plus x whole cube. 1 plus x whole cube. So therefore, now what is f triple dash at 0? So 2 by 1 plus 0 whole cube. Instead of x, you write 0. What do you get? Just 2 only. So likewise, so substitute back all those things here. Assume this is 1. So therefore 1 implies, substitute back f of x. F of x means ln 1 plus x. Ln of 1 plus x is equal to f 0 is 0. So 0 plus next f dash of 0. F dash of 0 is 1. So 1 by 1 factorial into x. Okay, plus f double dash of 0. F double dash of 0 is minus 1. So minus 1 by 2 factorial into x square. All the values I am plugging back. That's it. Plus. And third derivative is plus 2. So 2 by 3 factorial. Isn't it? Third derivative. So 2 by, right, into x cube, right? Next plus up to so on. If you want to connect one more term, then simplify later. So this is x by 1, okay, minus x square by 2, okay, 2 factorial means 2. Now 3 factorial means 6, right? So 2 by 6, that means 1 by 3. So plus x power 3 by 3. Look at same formula used there. Just recall. So minus next term you will get x power 4 by 4 you will get. Try to find out those things, okay. Plus up to so on. So this is ln 1 plus x expansion, Maclaurin series expansions. So this is about Maclaurin series expansion of ln 1 plus x about the point 0. Okay, with this I will stop.